So here we have our setup for the interference and diffraction experiment. Over here on the right, we have our laser light source at 650 nanometers passing through our interference grating, which is then going to show us a pattern over here. So as you can see right now, the pattern we're showing is one bright central dot surrounded by several smaller dots, which are getting fainter and fainter as we head further from that center. So beyond that, the point of today's lab is to observe both single slit interference, like we have going on currently, and dual slit interference, which we're going to switch to in a moment. So the point here is that we know exactly what we've set our interference at. We have our slit distance set to. And over here, we're going to be measuring out the number of these dots. So starting at m equals 0 from the center, and then 1, 2, 3, 4 out either direction, both negative and positive. So we're going to be using that and this relation here to try to show that we can back calculate what the slit distance is and that we're observing the pattern we should be seeing. Where b is the slit distance, which we're trying to confirm. Lambda would be the wavelength. L is the distance from our slit to where we're seeing the pattern. Y is going to be the distance from that center value to any of these smaller fringes out. And M is the number of fringes you go out from the center bright value. And so now we've changed it to have a dual slit interference pattern. It's going to use the same relation as before, but now what we're going to be seeing is a slight difference in the interference pattern that we get. So we can see when we have dual slit interference, that center fringe is far brighter and bigger than it was before. But you can still see the smaller fringes trailing out from the center, albeit you can see less of them. So that'd be the main difference between the two of them. And we're using that same relationship to try to confirm what we can see before. We know already what slit distance we're using, but we're trying to confirm that the math we have holds and that we're seeing the appropriate pattern show up.